So, good morning, everyone. Well, good afternoon, actually. Welcome to ETHGlobal, the first talk. And yeah, today we have some sweet things for you. Ideally, I'll be talking about some of the things that developers fall in love when you embrace them, when you discover them, when you think, okay, how could I be doing this before, right? Let's get started. So, we are in 1970. Welcome to Digital Equipment Corporation. The computer they released was called PDP. How did it work? The entire system was basically one program, right? And if you needed to change something, basically there was one program running the entire thing. There needed to be one program for every architecture. There was no way to add, to remove. It was basically something monolithic. But then came operating systems. So you have a trusted kernel that can basically do everything it likes. And then you have untrusted programs that interact with the kernel to do things so that you can have many programs and you can basically forget about what's behind. And how does this look like? So at the top we'll have, let's say, that is the network, basically the things that, the hardware itself. And then below, you have different programs that might need to interact to these resources. So for example, if you want to use Spotify, Spotify will talk to the kernel in a kind of standardized and abstracted way so that it can use the speakers, so that it can use maybe the network, display, whatever, right? But fast forward into the future, where are we, let's say, 50 years later in, let's say, 2017? Yeah, well, I think we're at the same place. Because back at the time, every protocol that needed to be made had to be made from scratch because there was nothing to build an abstraction on top of, right? So basically, writing the entire protocol every single time. There was no way to add and remove features. There was no way to, easily customize things. But then this started to change when Aragon in 2017 released Aragon OS, the first version. It was the first solution to a problem. It was revolutionary in many terms. And still as of today, it is unhacked. It's very robust. And it worked based on templates, right? So different templates for NGOs, for associations, for profit companies. And it was good for some of these use cases, but at the same time, it had some challenges for it to be used in simpler use cases. And some of the lessons learned is that there are not two equal communities. Two DAOs are going to always need different things. They are going to have different flows. They're going to require something unique to them. At the same time, the same DAO always evolves over time. You can start today and you have no idea of what your community is going to look like in the future, what you will need. And you cannot, it's super hard to design for this ahead of time. And another lesson being learned is that many times Aragon OS has been forked and has been implemented in, for very big projects like Lido, Decentraland, and so on. But the thing is that this is not ideal because you need to fork and maintain a big code base, right? So if you can extend instead of forking and maintaining the whole thing, that's a big bonus. And for this year, in 2023, March this year, we have released OSx, which is basically a massive leap forward, which consists of two components. So we have a DAO core, and then we also have untrusted plugins or external addresses, let's say contracts that can interact with the DAO core. Doesn't it sound a bit familiar to you? I think it should, because basically we're talking about the same concept of an operating system, which is there are some plugins, some contracts, some wallets that want to use the DAO, right? They want the DAO to do something with shared resources, pretty much like programs do in an operating system. So for example, if a plugin wants the DAO to transfer some DAI to another address, there will have to be some governance proposal on the plugin, but essentially the plugin will need to have permission to go to the DAO. And then the DAO internally has a permission database, which is basically the Bible of everything that can happen within this community, right? But then we've been talking, at least the title is about the Unix of Ethereum. Let's get a bit into this. What's the Unix philosophy? If you're developers, you're most certainly aware of some of the basic principles of it, which is writing programs that can do one thing and do it well, right? The components. building programs that can work together, that they can talk to each other very easily, that you can compose, that you can combine and architect something bigger than just the program itself that needs to grow indefinitely. And also flexibility. If you build small pieces, these small pieces should be able to work in many scenarios, not just for one specific use case, right? But should be reusable by many other tools so that, again, you can build more complex things and more interesting things. This is a very simple Unix program. All it does is just opening a file, reading some data, and reading it back, writing it back, etc. The blue dots here, the blue functions here, they are the absolute simplest things you can find. You don't have an open file function. You don't have a write buffer. No, you have a generic function that works everywhere for every single kind of thing. But on top of this, for example, with programs like the one we had here, imagine we compile this, we eventually have a layer on top in which we can start composing some of these programs, some of these binaries that we made to make something more interesting, more complex, and more accepted away. How do we translate many of these terms, let's say, for ourselves, for Aragon OSx? So in Unix, everything is a file. Okay, for us, everything is a permission because eventually you want to execute something, right? There are system calls like read, write, exec, etc. For us, there is DAO.execute, asking the kernel to do something. Permissions, for example, change mod, change group, change owner. Well, we have granting and revoking permissions. And then we have some of the basic utilities like ls, copy, etc., which are some of the plugins that we ship ourselves and some of the plugins that anyone can do. Can be multisig, can be token voting, etc. There are some additional guiding principles that we have inherited not only from Unix, let's say, but some other languages, like, for example, Rust. We like there to be only one correct way of doing things, right? We like clarity. We want developers to be explicit about what they do. If this code is going to be audited, it needs to be obvious what the code is doing. We don't want any hidden magic behind the scenes. At the same time, we want people in general, the community, to only pay for the gas for features that they need and that they are using. Just no hidden bloat, not just shipping 20 million things that you don't use, but they are there, right? And it needs to be easy to understand and to reason about. Because after all, it's all about security. So then, let's start talking about plugins, because Aragon OSx is basically about a community, is basically something valuable that needs to be protected by many people. There needs to be many people behind for this to be secure. And for this, we need plugins. What is a plugin? Basically, a plugin is our way to solve a small problem, a small custom problem, following the Unix philosophy. So make it simple and stop reinventing the wheel. Basically, reusing everything else that we as Aragon offer for free. Basically, plugin versioning, upgradability, so shipping new versions, allowing people to easily upgrade to the newest features that you ship, maintaining data, maintaining statuses, using the permission management system, which is one of the top most beloved things about the initial versions of Aragon OS. Also interact with other plugins, also combine different plugins together to achieve the custom scenarios that your DAO needs, and more that we're going to see pretty soon. So, and the end goal of this is stop reinventing the wheel, because we want to ship fast, because we don't want to, be rewriting things that have been already solved in the past. So how does a plugin look like? So first of all, the green box here is, let's say, the plugin that, for example, we would like to have a multisig. Okay. But at the same time, we're going to need what we call the plugin setup just above, right? What does this plugin setup do? It's a contract that the developer does, which manages installations, updates of the plugins, and uninstalls. It's basically a script in which you can do basically everything. On top of that, when you want to publish a plugin version, you publish the plugin setup. We have a registry, and then in this plugin registry, you can create your own repository. You even get an ENS if you want, and then you keep publishing different builds. If you choose your plugin to be upgradable, people will be aware that there is a new version. They can create a proposal, and they can get the latest and greatest features that you just ship to them, even yourself. And then on the other side, there are all the goodies to just make all of these accessible to UIs, to any applications that you can think of. So in the end, what's the landscape that this leaves us, let's say? So as I said, there are not two DAOs that are exactly equal. So most likely you could, for example, want to start with a DAO with maybe one multisig plugin, and then maybe eventually install another one, maybe install a token voting one. And maybe in the future, maybe you want to do off-chain voting and you install a third one and you decide that you want to remove one of the other ones. So you're basically decoupling, let's say, the shape of your DAO, the shape of your community, from how the actual DAO works. So for example, here at the top, imagine that there are many operations that the DAO can perform, many functions. These functions, they have different roles associated to them. When you install a plugin, you grant it some permissions, and depending on the permissions of this plugin, the address can perform these operations, right? But if tomorrow, for example, I decide to remove the multisig plugin, let's say I am doing a clean uninstall, and then I could install maybe not a multisig, but a token voting that could do the exact same thing, but with a different logic. So you're basically setting yourself to be feature-proof in terms of evolving, operating, without committing your DAO to be as it is today forever. So let's see some code, because my whole point in this presentation is to show you how easy it is to do a plugin. So this is the absolute most simple plugin that you can get. All you have to do is inheriting from plugin clonable, for example, or from plugin UPS. Upgradable. You get for free all of the tooling. You can just simply forget about the rest. In this example, we have a plugin. What it's doing is preparing a list of actions. And this list of actions, eventually, we connect to the DAO to which this plugin is linked. Let's say to which this plugin is listening to the permission database. And we're asking the DAO to execute these actions. That's it. That's the hello world. That's the hello DAO, let's say, plugin that you can build. What if, for example, our plugin wants to start using some additional permissions for itself? What if we want to restrict the plugin itself? We don't want just anyone to go there. We want some function to be guarded. So first of all, we will need to create here our own permission ID, which is basically a byte32 computed by hashing some value. And then below, on the function that we want to guard, we are going to add this modifier. This is the basic building block. Then only the people who holds the permission, in this case, my plugin permission ID, on the DAO's database is going to be able to use this. This is something fluid that you can grant, you can remove, you can evolve, you can iterate. You can have another plugin with a different logic. You can have a different version of this plugin with maybe fixing a bug, etc. So it gets really, really, really flexible for you to just evolve. How does a plugin setup look like? So there is the iPlugin setup interface, which is basically the method that your install script should implement. So this is a two-step process. Step number one, you prepare the installation, the update, or the uninstallation of a plugin. And then step number two, the DAO has a proposal, and eventually the community accepts and decides to apply the permissions that you have requested, and essentially the plugin becomes installed, updated, whatever. Here you have some example of one of our own plugins. So the multisig plugin, what you have is a constructor. We do the initial deploy to have, let's say, the implementation on-chain that we will then carbon copy. We don't need to deploy every single time, so we use proxies. So in this example, what we do is, pre installation, your function will receive some parameters that you're going to encode with the settings of this particular plugin. And then you can just simply copy this line that we provide you the tooling to just use it. And then this creates a proxy with your specific plugin instance. You get your very own plugin. And then the last step is requesting permissions. This may seem about verbose, but essentially what we're doing here is, well, we're building a list of permissions. So we're saying, please allow the DAO to upgrade the plugin settings, or please allow the DAO to upgrade the plugin itself. And at the same time, oh, please, DAO, allow the new plugin to do execute or to do something, right? So you do your wish list of permissions, and then the community assesses whether they like them or not. And eventually, if they approve them, these three permissions here are going to, make it to the DAO's permission database. Okay. So what is a permission? As we saw before, basically it's a source of entropy, a string, hashed, which is then a number, and we use it to shield functions. And permissions, they look like granting permission to who, to do what, on where. So allow the DAO to do this on the plugin. But what if we want things to be a bit more, let's say, more granular? What if we want some conditions to be a bit more restricted, right? So you can use permission conditions, which is nothing more than a contract that you can define, right? So, for example, when you have some plugin trying to execute some operation, you could tell the DAO, okay, whenever someone wants to perform this action, ask this contract. And if this contract says yes, you just continue, right? So they allow for us to basically decouple the fact of the features themselves with the restrictions. And this prevents things like plugins going super complex because you need to combine a matrix of, I want to do this, but not that, but yes, but no. It gets extremely complicated. If you can decouple these two things, again, you can have very composable, very modular things, very modular protocol without needing to reinvent the wheel, because most of the time some of these conditions will have been implemented by someone else, right? Same as plugins. Some of these plugins will have already been implemented by someone else, and you can just pull them and get, let's say, their upgrades for free as well. So in the end, permissions for us would look like grant permission to a certain contract to do a certain role on some target, optionally when a condition is met. And with this, you can just go and build the moon. So this is how simple a permission contract would look like. The only thing it would need to implement is basically the isGranted condition. It would receive the parameters of what is being attempted to do, and eventually it needs to return yes or no. In this case, first parameter being greater than the second one. So this is all I've got for you. There's much more. You can just find us, Carlos and Juliet. We will be here around. We have here a couple of plugin examples for you. So one is an example of a plugin to understand how it works. Okay, and the second one is more of a project in which you get a plugin, and you get also all of the integrated testing and some JavaScript client for it to connect on a UI. And also some basic subgraph indexing in case you want your UI to be more, user-friendly and all of this. Feel free to take pictures of these QR codes. At the same time, you can also go to devs.aragon.org and you'll get all the whole documentation of the protocol. And also you can join us on Discord. So some people from the community are very active, also helping around. And yeah, the TLDR for me is the sky is basically the limit. If you don't have to reinvent the wheel to build the next big thing, and you can focus on customizing only what you need and recycling everything that there's around, then basically you're ready to go build the absolute next big thing. So that's it pretty much. I'll be happy to ask many questions and expand any of the topics that you think.
Thanks for the presentation. I would have a question about the initial deployment of a DAO. Does the initial deployer or owner needs to write code as a smart contract to set up everything and to include plugins? Or is it just a call to an existing contract?
So you could decide to deploy it yourself, but most likely you will want to use something that we call the DAO factory. So you call the DAO factory, which is a contract that we deploy ourselves. It's there. And then you pass it a list of the plugins that you want it to have, right? So by default, the deployer, if you happen to deploy it yourself, you would be kind of having total permission on it with the intent of installing a plugin and then dropping this permission. And can give you more examples on that, absolutely. But yeah, there's a contract that does everything for you.
Thank you very much for the speech. Can you please tell us what are your most popular plugins for now, which you created, your team, and what are custom plugins your clients and other DAOs created that are very commonly used?
Mm-hmm. So we ship 4 standard ones. We ship the multi-sig plugin. We also shipped another variant which is called the address list, right? Which is a version of it which is intended for everyone to vote, whereas in a multi-sig, you only expect some people to just say, okay, right? In an address list, you have an explicit list of addresses, and they vote. And then you have the evolution of this, which is token voting. So you can vote with an ERC20 token, etc. It supports delegation. It supports many things that you expect. Then there is another interesting plugin. Interesting. We call it internally the dictator plugin, which is basically the admin plugin, in which one address is able to do everything. This is in cases that, for example, you need to experiment or you need to kickstart the DAO, right? You could manually grant permissions to yourself, but the idea of having a plugin, the benefit is that everything is encapsulated, right? You just add it as a whole and remove it as a whole. So you could start with this plugin, then upgrade to multisig, then upgrade to any of the other ones that you would say. Regarding what the community is doing, I don't know, maybe Juliet, Carlos can expand on this, but the idea as of now, the point in which we are, is people do their custom thing, right? It's not that they're just publishing plugins around. This may well become, let's say, the next step. But at this point, it's more like not needing, being able to recycle and just adding the extra plugin that does this very small thing that any of the existing plugins could not possibly solve for you. Not sure if this replies to the question.
Hi. Can you hear me? Yeah, I guess. Thank you for the presentation. I'd like to ask if I'm going to use the Aragon OSx, will I be able to use the auto-generated client as it is done on the Aragon app?
I'm sorry, I have a bit of trouble. Could you speak a bit louder?
Yeah.
So I can close the door. Thank you.
Yeah, thank you. So let's say I'm going to use the Aragon OSx to create my DAO. Will I be able to use auto-generated client as it is done on the Aragon app?
So what we ship is the Aragon SDK, which basically provides all the tooling to interact with basically web Ethereum, IPFS, and Subgraph. Okay. Then on top, we built abstraction layers so that you can interact with anything related to the DAO in general. But at the same time, we also, sorry about that. So the second example here, you get an example of a JavaScript client that uses the SDK, right, to just add the custom things that you need for your client, right? So the idea is that you get maybe 95% of the tooling there, and you can just right away start calling, Web3, call this contract, or IPFS, fetch this data, etc. So it's not auto-generated because the custom bit that only you know, you need, what do you want? We can't possibly know how you intend to use, for example, maybe you want to use the graph, or maybe you want to use a backend and index something there. Or maybe, there's no general rule here.
And last question, could I use SDK to work with already existing DAOs that are created from the client as well? From the app, for example, to fetch the data, to get all of the DAOs.
As long as you can basically call the contracts, as long as from JavaScript, you can simply fetch the information, obviously, So again, the message is, the SDK gives you all of the building blocks for you to build on top. We use it ourselves to build our own plugin clients, right? And you can just replicate this. Just write the custom 5% thing and forget about the rest because we did it. Good.
Again?